So for number 10, we want to find at least 10 partial sums of the series here. So the sum from 1 to infinity of 7 to the power of n+1 divided by 10n. And then we want to graph both sequence of terms and the sequence of partial sums on the same screen. So what I did here is I created this column where on the first, this table where on the first column, we just have our indexes. So it goes n is equal to 1, 2, 3, and so on until 10. And then for the second column, we have our an, that's our sequence, right? So that's just taking this formula right here and then evaluating for the different indexes. So for n is equal to 1, we're going to have 7 to the power of 2 divided by 10 to the power of 1. For n is equal to 2, we're going to have 7 to the power of n+1, so 7 to the power of 3 divided by 10 to the power of 2, all the way out to 7 to the power of 10+1, so 7 to the power of 11, divided by 10 to the power of 10. So that's just our sequence. And then on the third column, we're doing the sums, right? And so the sums, for the first one, we're just summing up the first term, which is 4.9. For the second sum, we're summing up the first and the second terms of the sequence. So 3.43 plus 4.9, which is 8.33. For the third sum, we're summing up the previous two terms, right, plus 2.401, and so on and so forth, all the way out to the 10th sum, which we're summing up all the previous nine sums plus the 10th value. And so we have here our table of the sequence and the sequence of partial sums. And what we're going to do is we're going to graph this. And so let us graph this. And so this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on the horizontal axis, we are going to have our n's. That's going to be our index. This is going to be our n. And on the vertical axis, we are going to put in our an and our sn. So let's see how I'm going to do this one. This one, I'm going to scale it every 2. So it's 2, 4, 6, 8, 10, 12, 14, and 16. Okay, so once we have this, I'm going to color code this. So I'm going to begin with an, which is in yellow. So the one in yellow is going to be our an, and let's plot it in. So for a is equal to 1, our value is 4.9, so nearly 5, that's about here. For a2, our value is 3.43, so that would be 3 about here, so maybe like so. For a3, we're going to have 2.4, so slightly above. For a4, we're going to have 1.68, so maybe about here. For a5, we're going to have 1.17, like so. A6, we're going to have 0.82, so that will be down here. And then we have 0.57, which would be about a quarter. And then 0.43, so closer and closer. 0.28. And lastly, 0.19, so that's going to be very, very tiny. Okay, we have plotted our an's. And now let's plot our sum. So we're going to plot our Sn, and remember the sum is just the sum of all our an's, right? So for the first one, we're only summing up the first, so that's exactly where the first an is. For the second one, we're summing up a1 and a2, so that's going to be 8.33. And that's going to be about here. And then we're going to have the sum of the first three, so that's going to be 10.73, like so. And then for a4, we're going to have 12.41. So a4, 12.41, about here. a5, we're going to have 13.58. So a5, we're going to have 13.58, maybe like here. For a6, we're going to have 14.4. So that's just slightly above. A7, we're going to have 14.98, so about here. A8, sorry, S8, I've been calling them 8, but it's actually S. So S8, we're going to have 15.3 15.39, and actually I drew this one a little bit too high. That should be here, and we're going to have 15.39, so that's here. For A9, we're going to have 15.67, and for A10, 15.87, so closer and closer. Okay, so let's see what happens. It's asking us to guess whether it appears convergent or divergent. And it does appear convergent to some value near 16. And the reason that it appears convergent is because we can see here that our ANs are getting smaller and smaller and smaller. So our ANs are actually tending to 0, right? And so if we keep adding terms that are closer to 0, it's like we aren't adding anything at all, and our sum is going to stabilize near some point. So it does appear that the series is convergent, but now we do have to check whether it is convergent, right? And so we have the sum here of from n is equal to 1 all the way out to, to infinity of 7 times n plus 1 divided by 10n. And I'm just going to change this, simplify this a little bit. Infinity. 7n plus 1 is the same thing as 7 to the power of 1 times 7 to the power of n divided by 10 to the power of n because of the law of exponents, which is the same thing as from infinity n is equal to 1 all the way out to infinity of 7 times 7 over 10 to the power of n, once more by the law of exponents. So once we get it looking like this, we can clearly see that this is a geometric the geometric series, right? So a geometric series has this kind of form, A, R, N. And so because our R is going to be 7 over 10, because the absolute value of R is less than 1, it means that the more terms that we add, those terms are going to go to 0, right? Just as we saw in our graph. And so because we're multiplying by 0.7, which is our ratio, it's getting smaller and smaller and smaller each term as we approach infinity. And so our sum is going to stabilize near some number, which is exactly what we saw in our graph, right? And so because of this, we can say that it converges because the absolute value of R is less than 1. We say, so Sn converges. And if you, so if we know that it converges, we can take the formula for the sum of a geometric series, which is A1 times 1 minus Rn, let me just clean this up, over 1 minus R. And so this here is the formula for the sum of a geometric series. So if you want the first 10 sums, right, the sum of the first 10 terms, we just need to put n here, so 10 in the value of n, and that gives us it. So we want actually the sum from 1 to infinity, right, which means that we have to take the limit as n approaches infinity of a1 times 1 minus r to the power of n divided by 1 minus r. So let us do that. And so this is going to be equal to A1 is the first term, right? Which is, as we saw here, it's 4.9. That's going to be 4.9 times 1 minus, that's going to be 7/10 to the power of infinity divided by 1 minus 7/10. So this limit here, 7/10 to the power of infinity, it's like we're multiplying over and over again by 0.7, so that goes to 0, right? So this over here is 0. And so when we have this, we're going to have 4.9 on the top, divided by 1 minus 7/10 is going to be 3/10. And so my result here is going to be 49 over 3, which is about 16.33 and so on. And so the sum is actually 16.33, which if we look at it from our graph, it tells us that story, right? That it's getting closer and closer to some value near 16. And so we have found that this series does converge and the sum is 16.33. And we were able to kind of make this guess through looking at the behavior of the graph.